Good evening all. You're welcome to Tutorial Suite from Eternity the Schoolboy. Today we'll take a look at chemistry, and we are still treating the topic separation techniques. In our last class we introduced separation techniques and we defined it. We also talked about what led to separation techniques. We talk about the advantage of what we take. What advantage do we take to separate mixtures, component of mixtures? What advantage do we take? We take advantage of what to separate component of or constituent of mixtures? Chioma? Chai. And you didn't collect notes or listen to the lecture. At least you should do one now. The lecture is on YouTube. If you miss lecture, try to listen to it. Okay? Did you hear me? If you miss lecture, try to listen to it or on YouTube. I post all these things. I upload all these things on YouTube. Or you collect, if you don't have the data to listen to it, or you collect note from those that we are in the class, so you can prepare your minds, so you don't look as if you don't get lost when you come to class. So Favor, tell us what advantage we take advantage of something to separate constituent of mixtures. Tell us. Say it anyhow. And correct me if you make mistake. If you make any mistake, yeah?
Advantage of separation techniques. We have I don't know how to put it.
No, I'm not asking about advantages of.
So what's the question?
I'm asking what they will take advantage of something to be able to separate component of mixture. I said it in this class.
We take advantage of something.
We were there. Success, tell us.
I was in the class now.
So tell us now.
Oh, 99.
So tell us.
Advantage. I don't know what I think, though. I don't know what I express. Let's say method.
Who help us? Martina, you were in the class. So tell us.
The differences of properties of the process of motion.
Perfect. We take advantage of the differences in the what? Properties. Specifically physical what? Properties of the what? Of the what? Constituent of a what? Mixture. That's the advantage, because they have different properties, different physical properties, right? Mainly physical. Please indicate physical. Indicate physical there. Physical properties. If you wrote it anyway.
Yes, nice.
Physical.
It's the physical.
But we take advantage of that. Don't you know?
Personally, just you ask us questions.
Must I ask you the way it was in your book?
No, if you ask it according to our book, or you went inside the line.
That's why you should read in between lines. Understand what you are reading in class. But seriously, is a very important point in separation techniques. Without, the component of mixture or the constituents of a mixture, they are not chemically bonded. True of us. They maintain their individual properties. You take advantage of the difference in their physical properties. So that's why you can separate them. Am I communicating? Good. One can sublimate, one may not be able to do what? So when you heat it, the one that can sublimate will do what? Go. True of us. One can dissolve in a particular solvent. One may not be able to do what? Dissolve in a particular solvent. If you bring that solvent introduce that solvent, one will dissolve. True of us. One may precipitate when a particular solvent is added. True of us.
Yeah.
And if you introduce it, that one will precipitate to do what? Form a precipitate. You filter. True of us. So you take advantage of the difference in their what? Physical what? Property. Mainly. Okay, chemical property is also there true in a way. Because when you go to precipitation, you know that precipitation is highly, before a precipitate will form, something would have reacted with two of us to form something else. Am I communicating? You remember your qualitative analysis in chemistry, O level. Remember, qualitative analysis, two of us. Good, right? Even though precipitation is anyway, when we get there, we'll talk more of that. Whether we talk more whether it is actually physical or what chemical. Let's not go too far. So, in that our last class, we talked about, we listed different separation techniques, and we said we'll take them one after the other. We started with what? Sieving. So we are done with sieving. What next? We discussed evaporation, right? So what next are we going to buy that in that order? Next one is what? Magnetic separation or magnetization, right? Now this one is simple. If you have actually magnetic separation or magnetization is used to separate magnetic solids from non-magnetic ones. It's used to separate magnetic solid from non-magnetic ones. That's what we use magnetization to do. You know, not all substances have magnetic some have and some don't do what? Have. True of us, if you have a mixture of iron filings and sand or any other solid that doesn't have magnetic property, if you have a mixture of iron filings and sand or any other thing that doesn't have this thing, once you get your bar magnets around it, iron will just leave the sand and go to the bar magnet. Did you do that in your secondary school?
Yes.
By doing, if you see iron filings mix it to sand, you will know which is with. True of us? Good. But once you get bar magnet, the iron filing will just leave the sand and go to the bar magnet. In doing so, you separate the iron filings from the sand. True of us? Good. So this magnetic this magnetic separation is used in steel industry. It's used in what? Steel industry. Steel industry. And also in tin ore. You know what is an ore? You know what is a metallic ore? A metal extraction, right? Good. It's also used in tin ore. You know, tin ore may have some magnetic impurities. It's used in tin ore to remove magnetic impurities. Tin ore. To remove magnetic impurities. To remove magnetic impurities. All right. So that's all we'll take a magnetization for now. What is the next one? In that order, what's the next one? Sublimation. Now, when do we use sublimation? Sublimation is used actually to separate solids that sublime from other solids. Solids that sublime from other solid. Of course, you know what is sublimation. In sublimation, solids change their state directly to gas without passing through liquid. So some solid, if you have a mixture of solid that sublime and solid that solids that do not do sublime, once you heat it, what will happen? The solid that sublime will just leave the mixture and they go their way as gas, right? You can collect them. If you want to collect them, you collect them in provide a cooler region where you can do collect them. By so doing, you have separated them. Example of such solid, of course, you have your iodine, the most popular one. Iodine, even ammonium chloride is also does sublime. So if you heat, then they will do they will go their way. Are we together? So because of this property of subliming, in fact, these substances like iodine and the ammonium chloride can be purified industrially using sublimation, okay? Iodine and the ammonium chloride can be purified industrially using what? Sublimation. Using what? Sublimation. Sorry, our reference book for today is New School Chemistry for Senior Secondary School by Oseyo Ababio, as edited by L.E.S. Akpanisi, as revised by L.E.S. Akpanisi, 2016 edition. That's our reference book for today. So let's continue. So, what is the next one we talked about? We listed distillation, both the simple and what? Fraction. So let's start with simple distillation. Let's start with what? Simple distillation. Okay, basically, distillation is actually used to separate solvent from its solution. Distillation is actually used to separate a solvent from its what? Solution. Remember when we discussed evaporation, we said that in evaporation, what component is of interest to us in evaporation? What component is or constituent is of interest to us in evaporation? The solute is of interest to us in what? Evaporation. That's why we sacrifice the what? Solvent. But in distillation, the constituent of interest to us is the what? The solvent. So it used to do what? Get a solvent from its what? Solution. Are we communicating? So distillation is used to recover a solvent from its what? Solution. Not only that, it is also when you have miscible liquids. When you have miscible liquids, it's also used to separate what? Miscible what? Liquid. Am I communicating? Do you know why it's used to separate miscible liquids? Do you know why? Especially the miscible liquid you can use to separate are those that have very wide gap in their boiling what? Point. Mainly in their what? Boiling point. Those that have wide gap in their what? Boiling point. Basically, that's what you use it to do what? Separate. Now remember, in our last class I made mention of that distillation process has two components. We have the evaporation aspect and the what? Condensation, right? True of us. Because the solvent need to do what? Evaporate. True of us. You will heat the solution, the solvent, but everything will be highly guided, so you don't sacrifice the what? Solvent. You heat it, the solvent will boil at its boiling point, change to vapor, and leave the solution as what? Gas. But you need to condense it to what? Liquid, using what you call Leydig what? Condenser. Lieddig. Leydig what? Condenser. Now what happens is, as it leaves the boiling pot that contains, if you heat the pot, well fitted in a retort stand, you know what a retort stand is? Well fitted in a retort stand, and they are in that pot, which you can use a Limea flask, round bottom flask, to do that. Now the solution will be inside that round bottom flask. You put a cork to avoid escape of the what? Solvent, because you don't want to sacrifice the what? Solvent. You put a cork, and now in the cork you now connect tube through which the evaporated solvent will pass through, and you guide it. The tube will pass through a condenser that is cooler. You provide that condenser, brings down the temperature so that the vaporized solvent on getting to that region where the tube pass through the condenser, the temperature will now do what? Bring it down. It will lose its, remember, law of conservation of energy. As you heat the solvent, the solution, you have impacted energy in the molecule. True of us. they will get energy to be able to escape the liquid. And as they escape, they will go up as vapor. When they pass through the water condenser, they will lose their what? Energy. True or false? And if they lose their energy, they will come back to what? Liquid. And you now guide it, the tube, and collect whatever that passed through that as what? Liquid. We call it distillate. We call it what? Distillate. So that thing you collect, the solvent you collect as liquid is called what? Distillate. So this is what distillation is all about. That's the process, the basic thing in what? Distillation. I don't know if what I say makes sense. So this is exactly what actually what happened. So that's why we say that here, of course, you need thermometer, true of us, to read the temperature. Now, if you heat the solution to vaporize that what? Solvent. Now the vapor pass through a what? Condenser, which will now cool it. And condenser have circulating water it is in form of the jacket. So when it cool it will lose its energy. Remember our kinetic theory of matter. It will lose its energy and become what? Liquid. And you then collect it as what? Distillate. So that thing you collect is actually the what? The solvent. Am I communicating? Then what you see in that round bottom flask where you started heating is just the what? The solutes and other what? Impurities. That's what you see. So just picture what I just said now. You understand what distillation. You can even draw it on your own, three of us, with what I explained, okay? So this is what distillation is all about. So where do we use distillation? In distilleries. Of course now, those people that produce dry gin, okay? Dry gin, ogogoro, aroma shinap, is from where? They use distillation there. Am I communicating? They use distillation in dry gin production, and as well as water, our what? Distilled water. We use it. That's where it got the name distilled what? Water. Because do you know when it happened? That solvent, if there is no source of impurity in the tube and the receiver that you receive it as distillate, that water is called distilled water. It's pure, very, very pure. But that's what they use it in labs. True of us, distilled water. Am I communicating? Am I communicating? Are you sure? Now that's what distillation is all about. Ask.
Yes, you said that distilled water is very pure. I'm not disagreeing with it.
Okay.
But distilled water is it healthy for drinking? Because I got to know that it does not contain culture.
That's what I'm saying. See, the point there is this. You know, when the water you are drinking undergo a lot of treatment, hope you know. Am I completing? You're not going to. There are some. In fact, there are some. They even incorporate a lot of this thing that will even help your system. Are you aware? Some they incorporate fluoride. True of us. The water you drink, normal water you drink. Am I correct? There are a lot of things there. But distilled water is not that it will harm you. But the point is that if what you are drinking is distilled water only, there's problem. Okay, that's the point. Okay. I don't know if I've answered your question.
It's not good for drinking.
No. What to drink is not distilled water.
Okay, that's
because what you drink has impurities. True of us.
Yes.
Are you aware?
Sure. Now.
So what did you define as impurity? If you add chlorine to your water, if you add chlorine to your water, the water they supply you drink, does it have chlorine?
Chlorine is not used for purification of water.
So if it pure? As when you talk about, if you want to fight bacteria and add other things to help, it's no longer pure. As in chemistry, the pure thing in chemistry we know is only water nothing else inside. It's not true. Is it pure? It's not pure now. Even though it's healthy, but is it pure? It's not pure. If you treat it with something, is it still pure?
There's one, there's one that they used to add inside water until we change it taste automatically.
No, understand where I'm going to. I'm going to somewhere.
Or is that one pure?
Chemically, by our definition of pure substance, chemically, if you treat water, the water we drink is treated water. Hope you know. If you treat water, is it still pure? It's not pure now. Am I communicating? Maybe you add other things that maybe you think that you need fluoride for teeth, or you need whatever iodine, whatever you are adding, whatever it is, or you want to treat it, whatever you want to do, blah, 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 before you supply, it's no longer what? Pure. It's only distilled water that you can still say is what? Pure. That's why I said, depending on the where, if the two, of course, before you can say it's still pure, you should be. You should make sure that the tube is passing through. Is also what? There's no impurity there that will contaminate the two of us. I'm not communicating, but at least it starts a high. The percentage purity there is very high when it comes to what? Distillation. Am I communicating?
That's why that's our.
Yes.
Our chemistry teacher.
To ensure that, listen, do you know why it's used in the labs? If you are saying that you are using water, other water, you will not introduce anything that will trigger the reaction. Hope you know. If you say you are using water, that's why you use the same water, because that's a reaction you are carrying out. There may be some component in there that may react with what reagent you are using, and you start producing something else. You think you are producing what is it called? The product you ask for. Does it make sense? Good. So what is the next one? Yes. Ask. Wait. Ask question. Ask.
This is about distillation.
About what?
We have distillation.
Okay.
Under it, we have simple distillation and fractional distillation.
We are done with simple. We are about to enter fractional now.
Okay, do your tissue. Let me move it.
Then you know what? So you're calling it step by step, right? You just called distillation. I ask you, do we start with simple? We started with was simple. After simple, the next thing you're going to know is fractional.
Okay. No wonder you said that in distillation. Now I recall that what you are referring to, because under distillation, you want to talk about that miscible liquids that with widely different.
Good. Okay.
It's under this simple distillation. I thought you actually define distillation as a whole. Yes,
okay.
that was what I wrote.
Okay. Now let's go to what? Fractional. Fractional distillation. Now, one thing with fractional distillation is this. Fractional distillation is used to specifically mixable what? Liquid. And for you to actually, there are some liquid that have a lot of fractions, okay? A lot of what? Fractions. Petroleum. There are a lot of things. I hear that there are a lot of things in what? Petroleum. True of us. In crude oil, there are a lot of things in what? And most of them have very close boiling point. Very close what? Boiling point. That simple distillation cannot do what? Separate. Okay? Because simple distillation can deal with wide, but this one, simple distillation cannot do what? Separate component of petroleum. Am I communicating? Now, they have close range. In fact, their temperature, the difference in their boiling point should not even be more than what? 10 degrees what? Say 10 degrees what? Celsius. It's not more than what? 10 degrees. You see that they are different, maybe 1, 2, or even 0.5. But not more than what? 10 what? degrees what? Celsius. Now, of course, when we go into organic chemistry, now that's when we appreciate this thing very well. When we go into refining of petroleum, that's when you appreciate this thing very well. By the time we enter organic chemistry, we take time and go into the processes involved. Okay, the processes, but just understand that this is used to separate what. So when it get to its boiling point, that one will separate and be collected. It's a column. In refineries, you see at different points, different temperature. When you get to each temperature, this one will boil and do what? We do what? Collect. Be collected. Am I communicating? At the end, what will be left behind? You see the solid residues like bitumen. True of us, bitumen. Is it bitumen or is bitumen that remain? And these days, bitumen can also be used in place of coal tar. True of us, in tying what? Roads. Are you aware? Are you aware? So that basically what happened. Apart from this separating them into their different fractions, it employs the same principle with what? Simple what? The basic principle is employing difference in their what? Boiling point. But difference here is that there are different can separate a lot of fractions. You know, boiling point can just separate those with wide range of what? Boiling point. True of us. But this one, different fraction, they may have close boiling point. That way you have applied a fractional. That's where the name came from. Fraction, different fractions. Fractional what? Distillation. When you get a petroleum and you see a lot of things coming out. To go to a point, you are premium motor spirit, you have fuel, the one you call fuel will come out. There's level you use, even the gas you use in cooking will do what? Come out. True of us and other things. So, but when we go into this thing, what is it called again? Into organic chemistry, we take time to do what? We take time to do what? Good. We take time to do what? Of course, you don't need to be told that this thing is in what order? Ascending order of their what? Boiling point. I hope you know. At the one that have a low boiling point to come out first. As the temperature is increasing, right? The one that come out at higher temperature will do what? Come out. That's how you keep going until you get the last fraction. So that's basically what happened what? Here. Okay. So, of course, I've told you that it's used in what? Refining what? Crude oil or petrol. You call it petroleum or crude oil. You call it petroleum or what? Crude oil. That's industrial use of it. Okay? So, that's where is when the crude oil or petroleum is refined. At different temperature, you see petrol come out. The one you use, you see kerosene. Even the kerosene we use, are you aware? Will come out. Even the diesel, are you aware? Diesel will also do what? Come out. And other heavy oils, the natural gases will come out. Then bitumen will also come out at different what? Temperature. That's basically what happened in fractional what? Distillation. Okay? That one is simple distillation. That one is simple what? Alcohol and water is simple what? Distillation. That's what, remember I told you, okay, don't worry. It's employed in gin what? Distilleries. True of us? Good. So if you have alcohol and water, you can use what? Simple distillation. Okay. The next one is what? Yay! Ask question now.
Why is it that? Yes, I know quite well. In that assignment,
Okay.
mixture of petrol and water is used for the preparation of formula. Why is it that it's not distillation method cannot be used to separate it?
Mixture of what?
Kerosene and water.
Kerosene and water. They are immiscible.
Are they miscible?
I told that.
Are they miscible? Are they miscible? Remember I said, yeah, come. Are they miscible? That is the first question. We say miscible liquids. That so you can easily do what? Separate them. You can because they are not miscible.
The separation formula is only for liquids that are immiscible.
Yes.
We did this thing.
It's okay now. It is. All right, let's go. Next one is what? Crystallization. Okay. The simple one, right? Okay, let's go. Now, whether crystallization, whether simple or fractional, is used to do what? Separate what? Solid from a what? Solution. Are we together? Solid from a what? Solution. Evaporation and crystallization, they are both used to separate solid from what? Solution. Am I communicating? The solid from the what? Solution. But the difference is this. You know, evaporation involves heating, right? Yes. Good. Evaporation is used for solid that are what? Stable to what? Heat. Okay? But crystallization is for solid that are not what? Stable to what? Heat. If you heat them, they will do what? Turn to solid. True of us. So you don't use evaporation to separate such what? Solid from their what? Solution. Am I communicating? That's what one basic thing I need to do what? Understand. So crystallization is they are used to do what? Separate salts that are what? That decompose what? Easily on heating from their solutions. They need to separate solids that, or example, salt that easily decompose if you heat them. So if you want to separate them from their solution, use what? Crystallization. Now, after that crystallization, there's one significant thing that happens. These things that you get after crystallization, most of them usually have contain what is called water of what? Water of what? Crystallization. Water of what? Crystallization. So, now, but that doesn't mean that you don't apply heat at all. Oh. Am I competing? But not that you start heating it until the solvent go. The solid will do what? Decompose. So, example of such you can separate like that is what? Copper sulfate salt. True of us. Copper 2 tetra what? Also sulfates what? 6. You have even copper 2 triisonitrate what? 5. Nitrate 5. Copper 2 tetraoxosulfate 6. CuSO4. We have here copper 2 trioxonitrate 5. Cu what? Brackets NO3 bracket what? Subscript what? 2. Then you have iron 2 tetraoxosulfate 6. Iron 2 tetraoxosulfate 6. FeSO4. Now when you separate them, they will now appear, if they are separated now, they now appear as what? Hydrated salts. Now you start seeing iron 2 tetraoxosulfate 6 pentahydrate. So write that same iron 2 after separation. Now you remember you say that they normally contain what? The crystal you obtain from through crystallization normally contain what? Water of what? Crystallization. Now in copper 2 tetraoxosulfate what? 6. You now see copper 2 tetraoxosulfate 6 pentahydrate. By pentahydrate, you mean that it has 5 molecules or 5 moles of what? Water of what? crystallization. Just write the same copper 2 tetraoxide 6. CuSO4. You put dots, then put 5, then H2O. That is copper 2 tetraoxosulfate 6 penta. Penta is 5. Penta what? Hydrate. CuSO4 dots 5 H2O. See it here. CuSO4 dots 5 what? H2O. This is copper 2. Remember, anhydrous one is normal. Copper what? But the hydrated form is what? Copper 2 tetraoxosulfate 6, then pentahydrate dot 5 H2O. Now another one, you also see copper 2 triazonitrate 5. We have stated the formula of copper 2 triazonitrate 5 as Cu bracket what? NO3 what? 2. Now as hydrated salt, when you now have this water of crystallization, you see something like 5 what? Trihydrate. The commonest one, you see what? Tri what? Tri means 3. 3. Water of what? Crystallization. Oh yeah, Chioma, come and write iron 2 tetraoxosulfate 6 heptahydrate for us on the board. Come and write it. Don't say it with your mouth. Come to the board. Iron 2 tetra. Come to the board. Iron 2 tetraoxosulfate 6 heptahydrates. Write it for us. Iron 2 tetraoxosulfate 6 heptahydrates. Iron 2 tetra, that 2 should be in brackets. Iron 2 tetraoxosulfate 6 heptahydrates. Six heptahydrates. Heptahydrates. So write the formula for us on the board when you are done. Write formula. It's not true. I don't believe you. Think about it. Think it through. Okay? But you wrote, did you write copper 2 triazonitrate 5 in your sorry, did you write iron 2 tetraoxosulfate 6 in your book when we are calling it? The formula.
I didn't write it.
Are you serious? What is formula for? What is the symbol for iron? Iron is what? You don't know. How? AU. Is that iron?
Yes.
Oh, see, yes. I write it. I write FE. Write it FE now. Yeah, continue. Then sulfate SO4. And continue. Then add heptahydrate there. Then put heptahydrate. Now hepta means what? Hepta means what? 7 now. It's not 7. Hepta. Hepta is 7. Oh yeah. Write it there. Hepta is 7. Oh yeah, hepta. 7. Write 7. Put dots. Write 7. Then write water. Formula for water. Put 7. Put dots. Write 7. 7. Continue. H2O. So this is iron 2 tetraoxosulfate 6 heptahydrate. It's okay. Go back. Go back. Now listen carefully. There's something I want to say. I want to talk about something. And it's something very serious. is something very, very serious. As somebody in teaching line, we've seen a lot of things. And if you know me, I say things the way they are. I don't mince word. If you want to be angry, be angry. I'll tell you the truth and simple truth. I need your attention, please. Just stop right in a few seconds. We can continue. I need your attention, please. Listen carefully. Our education system has been messed up. To be sincere with you, okay? So, and that thing is affecting a lot of people innocently. It has become systematic that you don't even blame the student. It's the system that conditioned them like that. Am I communicating? Good. When we are still in secondary school, coming up, you write your work by yourself. Those that are doing this malpractice, they run into the bush to do it. Am I communicating? They travel to inside one village. With that we are calling it outside Wayek. I don't know what people are calling it now. They run inside one village to write their Wayek, and they were hiding. That time, very strict, but now it's no longer what it is now. I've never gone to where they write Wayek, but when you see things, when you see some certain things, the truth be told, at this level, we should know how to write this thing. True of us. That's the truth, whether you like it or not. It's a sincere, I am sincere with you. If I discuss with you, I don't need to be there when you wrote your work. Once I discuss with you, teach you, I will know whether you wrote it yourself or not. In fact, I will even know to listen whether you are even the one that entered hall to write. You know there are different steps. So we enter hall, and they will be allowed them to be asking questions, and they will write it. Is one category. If you are in that category that asks questions you are told, I will know. If you are in a category that you didn't even enter the exam hall, I will also know. Am I completing? But whatever happened in the past, it may not be your fault. Don't feel dejected, don't feel bad that you cannot do this and start feeling bad. You have taken the right step by telling yourself the truth and looking for solution. I call it freeing of gap. I used to tell my students, I don't hide it, that most of you have a lot of value to do what? Feel. And if you don't feel that value, it will affect your confidence. Even when you succeed, exam in school here is just what you are taught. You can cram it and pass. True of us. True of us. Good. But those fundamentals you missed, it will affect your confidence. There are some things that you don't talk about. You go and hide because you don't know certain things. True of us. And it will be a very big shame that you parade yourself as a pharmacist. One day, you may graduate here. Maybe those that they will do it the way they have been doing it. You see yourself in one pharmacy school. Some even travel outside where they don't have time for all those things. They will enter one pharmacy school and graduate. And you go out one day to go and do something. You don't know how to write this. What type of pharmacist are you? Am I competing? So if you know you are in this category, don't worry. That's why you are here. We are starting from the beginning. We'll take it step by what? Step. After this now, we'll go into formulas, elements, formulas, symbols. You will learn it once you put your heart in it. Am I competing? So don't feel bad. Don't feel bad. You may look as if you are embarrassed. Yes, be embarrassed to learn something. If you keep to yourself, you will not learn, okay? Good. That's what I want to say. It's a very important thing I want people to know. There are people that are even in that hostel. They have the money to come for lesson. And they don't know some of these things, but they don't care. One day you see yourself, maybe you assume you're in a better position. You don't know tomorrow. Maybe you are a brother that know your brother, that know your sister, may link you up. One day you become one big person in the future as a minister. You know now the system. The minister or one important person there, you come out to, and you must talk about some certain issues. Then you talk about some things that you didn't have the confidence to talk, because you know that there are some things you are being what? Lacking. and it will keep limiting you. So this is time to build up some values you know ourselves, you have. Fill it up. Something that they have arrived, that these basic sciences are nothing. Maybe they do one or two things in where I can make it, and they are here. They think that they have arrived. They have not even started. Because to go to a point, they will realize that they have not what? Started. Okay? So don't feel bad, okay? You are here to learn. Now let's conclude with crystallization and call it and stop here. Now we just mentioned the examples of substances, right? Now another point I want to make here is that how do you now crystallize? How do you crystallize? Now, first of all, remember I said you will heat what? You apply a bit of what? Heating, right? Now, if you heat the solution first. You will heat the solution first. We are not into the process now. You will heat the solution first. But your intention of heating the solution is not for all the liquid solvent to go. If you try it, the solid may decompose. True of us, the solid may decompose. You heat so that some of the solvent will do what? We evaporate. Now, of course, if you see a solution and you heat a bit and some of the solvent now evaporates, what will remain will be a saturated solution. True of us, it will what? Somehow what? It will be saturated. So now that saturated solution that you have produced by removing some of the what? Solvent, you will now cool it. You do what? You cool it. As you are cooling it, so the solid will come out as small as what? Crystals. You see it as solid coming out when you are cooling it. But if you want to quicken it, you want to induce it to come out, there are two things you can do. The first thing, you can either add, that's what we call seed. Seed. We call it seeding. If you want it to come out, you can induce it by yourself. By getting that particular, if what is inside that solution is copper 2 sulfate, you get that particular pure copper 2 sulfate, just some, and add in that saturated solution. It will make the copper 2 sulfate this to come out fast. Okay? It will do what? Crystallize out fast. We call it seeding. You can add a seed. Just get that copper 2 sulfate, pure one, and add. It will come out fast. Another thing you can do to make it come out fast is that in that container that contains that thing, you scratch it and you scratch that container. If you scratch that rough surface of that container will make it to do what? Crystallize out what? Faster. Am I communicating? Naturally, if you cool, it will start crystallizing now. But if you want it, you can induce it to make it faster come out. You add the seed. By seed, I mean that particular what? Salt inside the solution. Add it. Get the pure one and add. It will crystallize out fast. Or you scratch the body of that what? Inner wall of the what? Container. Scratch it. Create rough. That rough surface you created will make it to do what? Crystallize what? Out what? Fast. Okay? So scratch the inside of the what? Container. Now, where do we use crystallization? Where do we use crystallization? Of course, hope you know our interest in crystallization is still solute. Hope you know. Is still what? Solute. But the solute, why we don't use evaporation completely is that the solute is what? Can be decomposed by what? Heat. So this is used in the manufacture of what? Drugs and sugar products. Drug and sugar production is used in drug manufacturing and sugar what? Production. Do you know why? Most of the drug on heating can decompose easily. True of us. Okay, when you come out up a bit, I think most of all of you are pharmacy technicians. When you come up, you understand what I'm saying. Most of the drugs, some of them are protein, some of them can easily be decomposed by what? Heat. That's why they'll tell you drugs should be kept in a what? Cool. Good. And remember, if you expose it extreme temperature, they can do what? Decompose, and it will affect the active ingredient inside it. Okay, have you been taught active ingredients? Don't worry, you learn that one soon.
Of this one is that once enters inside it.
There are some that can easily react with air and have issues. Okay, that's why you put it in airtight container. Okay, don't worry, you get to know those ones. Now, even in sugar production, the sugar withstand heating? If you heat it, it will char, right? For a long time, it will char, right? That's why you don't separate a mixture of sugar and water with evaporation. If you try it, it may char. True of us?
I thought it's that method.
Sugar and water. Okay, so what happened? As you are eating it, be careful.
Yes, you told us that we had the thought of maybe that while eating it will be shaking.
I'm saying now. So why in industrial scale, don't use it. The actual one, you can use what? What is it called? Crystallization. I'm not completing. It's not a wonderful. Remember, I told you that a mixture of sugar and salt and water. You heat it a bit, water will go, but you cannot completely. You can't have it so dry. It will still be damp. If you want it to be so dry, it will char. True of us. So to get it as dry as you want it, use what? Crystallization.
So in the exam, if they see separation of water and sugar, and we see evaporation, and we see crystallization, and we see distillation, decantation.
And if you think they ask that in the jam, so
Use crystallization.
then distillation should be the best.
It's going to give exactly what you want. Remember, in crystallization process, you will heat a bit to remove the solvent, but what will remain will still be what? Saturated what? Solution. True of us.
Okay, what about water and salt?
Hey, or sodium chloride. Salt. If the salt is sodium chloride is stable to heat. That's why you use evaporation. You can heat it to water will disappear. It will remain where it is. Does it make sense to you? So I think we have actually. It's 6:09. We'll stop here. I have another lecture by 6 p.m. That's why she came, and she's waiting for me. So I think we'll stop here, so I can move to other things. Any question?
But sieving and filtration are they
Sieving, they are not, even though they are separating, but sieving, they are not exactly. They are certain. What's that?
Solid, not liquid. Liquid is liquid and solid.
Are you okay now? I think we'll stop here. So you can go to your house, rest, and study. Wait, when do you even study? How do you manage your? When do you study? Please, if you go back, rest, eat, rest, try and sleep. At least you can wake up as early as and study. When do you wake up? When do you wake up? You woke up by 4. When do you sleep? Why by 12? Okay, you read till 12. No, if you read till 12, it's okay. Hello? If you read till 12, then sleep and wake up by 4. It's not bad. But if you just go to say and gist to then sleep and go by 4, sorry, your time is going. You are wasting time. Okay? You are what? Wasting time. Just go. If you are not the type that read in a noisy place, just try and sleep. No, you have to do it too, so you can have time to study.
There's time for sleep, there's time for rest.
Everybody is not.
Know yourself. All right, thank you very much. And God bless you.